This next video is going to help you with vertical motion model problems, specifically thrown problems that have a negative velocity. Now, right now I still have the graph up from my last video. A really good rule of thumb is to always do a zoom 6 after you're done with the problem to go back to a standard window. So I'm going to go zoom 6, and then I can go clear out my y equals because I'm going to be plugging new information in. Alright, so now I can actually read the problem. Just like with dropped problems, you are going to sketch your graph, label any important points, which are your intersections, and state your answer. We're going to round to the nearest hundredth, and we can't forget to include units, and we will have to adjust our window for every problem. So a hawk sits 50 feet up in a tree and sees a mouse on the ground below. The hawk dives downward with a velocity of 25 feet per second. How long will it take the hawk to reach the ground? The number one thing people mess up is with this downward velocity. People do know, hey, I've got to use this thrown model because it has velocity in it, but they don't know what to do with the fact that it's downward velocity. So that's what we're going to practice right now. H is end height, where this object ends up. So since the hawk is going to the ground, our end height is 0. We're looking for time, so we'll leave the negative 16 t squared alone. And now here's the important part. The hawk is going downward, so our velocity, we're going to have minus 25t. Not plus, minus, because it's downward, and then plus our starting height, which is up at 50. So here's your equation, and now we're going to use our calculator to do the rest of this for us. So whatever is before the equal sign goes in y1, whatever is after the equal sign goes in y2. I'm just going to plug it in. You can use an x instead of a t. Let's graph this. Okay, we can't really see the top, so we should definitely change our window. This hawk started up at 50 feet, so I'll type window, and I'll change my y max to something bigger than that. And this should help so I can see the whole picture. Okay, there we go, much better. So now we're going to sketch this. And it doesn't have to be perfect, but it should resemble the picture. So you should notice that it just shifted to the left. The y-axis doesn't cut the parabola right in half, like my last video if you watched that. So it's a little more like this. And then also, we are looking for where the hawk hits the ground. So your intersection points are here. To find those, we do second trace 5. Over to the left, 3 enters. And we want to round to the nearest hundredth. So that's a negative 2.71, comma 0. And then we'll do a second trace 5 again. Over to the right, and 3 enters. And 1.15, comma 0. That's your second intersection point. So far we have done everything except actually give the answer to the problem. How long will it take the hawk to reach the ground? Well, a hawk can't take negative amount of time to get to the ground, so we use our positive answer. It takes 1.15 seconds. And there you go.